With that, I think we'll go ahead and get started. So just first off, a little housekeeping. If everyone can keep their microphones muted during the presentation, that would be fantastic. And you can put your questions in the chat box on the side. And at the end, Rebecca will go through and answer all the questions. We'll have time at the end for questions. So please keep the questions coming, and then we'll just get them all at the end. So thank you, Rebecca, first off, for doing this webinar as part of our Orca recovery event series that we have. We asked Rebecca if she would talk about the Pacific lamprey because she has just done so much research on them. And that, since it kind of comes back to the Elwha Watershed and the importance of the fish in the Elwha, tying back to Orca recovery. So she's putting on this webinar for us, and it will be recorded. So if anyone needs to jump off early or knows of someone who would like to watch it after the fact, we will have it up on our website. And if anyone still would like to join us for some of our Orca recovery events, we have a walk on Little River tomorrow with Mackenzie Taylor with the Lower Elwha Clallam Tribe. That's going to be from 2 to 3 o'clock in the afternoon, and there's still registration spots open for that. And then we had to move all of our volunteer plantings for later in the month since it's been such a hot, dry fall. I guess we haven't had any water, any moisture, and no rain in the forecast. So we pushed all those out to the beginning of November. November 2nd, we'll be planting on the Quileute River. And November 5th, we have a volunteer planting on the Elwha River down at the former Lake Aldwell area where we've been doing quite a bit of planting before. I think this will be our 4th year down there planting for Orca recovery. And then our last planting will wrap up on November 9th down at Edis Hook. So hope we can see some more of you out there helping us with those. And with that, I'm going to go ahead and turn it over to Rebecca. And thank you again, Rebecca, for doing this for us.
Yeah, no problem. Thank you, Megan. So I am Rebecca Mahan, and I work for Clallam County DCD department. I am a habitat biologist there, as well as the coordinator for the Clallam County MRC. I have been with the county for about 1.5 years now, and before that, I worked for the Lower Elwha Clallam Tribe for 14 years as first a student, and then a technician, and then as a biologist. So, and that's where I was first introduced to lamprey, and where I kind of really found a real love for them. And so and it started way back as working as a technician. So I'm gonna just kind of give you like a brief kind of overview of what a lamprey is and why they're important, and then we'll talk about dam removal a little bit, and then we'll go into some of the genetic results of the study that I did. And I am going to stop my video just because my internet is a little bit spotty at times, and I don't want it to freeze up on me. So this picture is actually the first documented spawning Pacific lamprey in the Elwha River. This is Madison Creek, and Amanda Anderson got this picture for us. She was walking out there with her children and happened to see the lamprey spawning, and this wonderful picture. Oh. Okay, now I'm not advancing. Oh, there we go. So lamprey are ancient fish. They are the second oldest fish alive today on Earth, and they're the class of vertebrate fish, Agnathia, and Agnathia means without jaws. And fossil evidence suggests that they have existed for around 450 million years. They're cartilaginous like sharks, so they're not bony. And so the top picture is the fossilized amosete of a lamprey, and below is modern day lamprey. And so they're virtually unchanged over that whole for millions of years. There are 3 known species of lamprey on the Olympic Peninsula. The Pacific lamprey and the river lamprey are both anadromous lamprey, which means that they go out into the salt water and then they come back into the fresh water. There's also the Western brook lamprey, which I actually got to see spawn in the Hoh River this spring, which was really cool. all these species are species of concern federally and in Washington state. And so when we talk about a species of concern, it's defined by ESA as the Endangered Species Act to species that are declining or appear to be in need of concentrated conservation actions. A species of concern are those species which NOAA, the National Marine Fisheries Service, has some has some concerns regarding the status and threats, but for which insufficient information is available to indicate a need to list the species under Endangered Species Act. So this is the life cycle of a Pacific lamprey. And so they are filtered. So they start off as, well, we can start with the spawning adults. So adults will come into the fresh water from out in the ocean, and they make nests, and it's usually a pair or could be more that make a nest. And so their nests are pretty much look like a red of like a steelhead, but a little bit smaller, and they're rounder. So their eggs will hatch in approximately 2 weeks into a prolarva, or what we also sometimes call an eyelash. And we call them that because they're the size of an eyelash. So at this stage, they kind of float downstream, and then they find some fine sediment, and they burrow in where they're filter feeders in that freshwater system for 3 to 10 years. And then in between those 3 to 10 years, they'll transform into a juvenile. And that transformation can take 6 to 9 months. And I like to compare it to the smolt transformation that salmon do. So the lamprey will, they're about the size of a pencil, and so they're going to be silver. They get their eyes, they get their mouth parts, and then they leave to go out into the salt water at this stage. And then once they get out into the salt water, they are ectoparasite for up to 7 years on a larger fish. And so this is the amice up close, and so this is the larval form. And so they're filter feeders, which means that they filter and clean the water. And so as they do that, they incorporate diatoms and detritus and algae and other organic material from the water into the food web that makes them grow. And so then they're also food at this stage for small salmonids and other fish. I've actually seen juvenile coho eat these little guys. We were out electrofishing for them, getting them up out of the sediment, and the little coho were going right in and grabbing them. And so this little, I always like to show this picture because I think it's really cool. This amice we got in the screw trap in Indian Creek, and it's actually got 2 tails. And so we're just kind of thinking that it's just developmentally 2 eggs kind of form together, but it's kind of cool. We also get some white ones, which we kind of call albinos, but we haven't actually done any genetics to say that they are, but so they do have a little bit different color patterns. So the juvenile phase is called a macrothalmia, which means big eye. And so like I said, it's kind of their smolt phase, and they get silvery, as you can see. And so this is also from Indian Creek. We got in the screw trap that the Lower Elwha tribe has. So this is a sculpin eating one of these macrothalmia. So they're also food for resident freshwater fish. We've actually lavaged larger salmonids and trout, and we found them in their bellies as well. So they're food for terns and gulls. And they also, when they're in large numbers, can shield for migrating salmon as a macrothalmia, but mostly as an adult. And so the adults, so all these pictures are from fish that we've gotten locally, except for the one on the on the plates. So the adults, like I said, are thought to be a shield because they come in the spring, and if they're in large enough numbers, the predators will feed on them, and that way the salmon can get by. When they come back in the fresh water to spawn after being out in salt water, they bring in marine derived nutrients. And so unlike salmon, lamprey do not home into their natal stream where they were born. They're considered panmictic. And another panmictic species, which everyone's familiar with, is the Colombian black-tailed deer. So the deer that we have here, which means that like a deer from Squam is going to be just like a deer from Port Angeles. So Pacific lamprey are considered panmictic like that too. They actually go in, they are driven into fresh waters by pheromones given off by the amicetes in the sediment. And this one in the bottom here, you can kind of see, this is a gravid or pregnant female, a female full of eggs. And upon capture, she was ready to spawn. So we made sure to return her right away, and she came out of Indian Creek. And they're also a lot of tribes, so they're native all along the West Coast, and a lot of the tribes depend on them for a food source. Up in the Columbia and Nez Perce and Yakima. Also in England, lamprey are considered a favorite dish. So this, hopefully I can get to play. This video was taken by Amanda Anderson the same time she took that picture of these spawning lamprey in Madison Creek. It was hard to kind of get both of those in there, she said, but we at least get an idea of what they look like underwater. So this is two different lamprey nests that were in the Elwha. And as you can see, they're kind of, so the lamprey use their mouths to pick up these rocks and move them around. It's actually very cool to watch them do that, use their mouths and their tails to excavate and place the rocks neatly around in a little bowl shape. And a female can have up to 100,000 eggs deposited in a red at a time. So what's the lamprey's role in the ecosystem? So like I said, they're filter feeders and they improve water quality. The juveniles and adults are high caloric food source. So they have 8 times the amount of fats and oils as a Chinook salmon. They provide marine derived nutrients to freshwater systems as adults, and they come in to spawn. They do only spawn once and then they die. And they're also culturally important for food and medicinal purposes with Native Americans. And I was at a conference and there was a Warm Springs tribal elder, and he told us that he grew up, they would harvest the lamprey and then they dry them, and the tails they would cut off and they would give to teething toddlers. So there's a lot of essential fatty acids in these lamprey, and so that would soothe the inflammation of the gums on the toddlers. And so I always think of that when I talk about lamprey. I think it's pretty cool. And lamprey, there's also been a dramatic decline in lamprey numbers in the Columbia, Snake Rivers, and everywhere. Because the adults are easier to catch than salmon, like I've said, they are a really great food source for larger marine mammals like orcas and seals and birds. And so what are the threats to lamprey? So the threats to lamprey are basically the same threats to salmon: habitat degradation and reduction, poisoning to control non-native lampreys. So lampreys have a bad name because everyone associates them with the invasive lamprey over in the Great Lakes. And so they're a distant cousin of the Pacific lamprey, but like I said, lamprey are native to the West Coast. Also impassable culverts and dams. So lamprey are poor swimmers. They can't jump and they can't navigate 90-degree angles. So their mouths are like a suction cup, and that's how they move. They can move up smooth surfaces really well, but they can't jump to get up into a culvert. And a lot of these culverts and dams, they have 90-degree angles. And so if you think about a suction cup on like a flat surface or a window and you get to a 90-degree edge, it's going to lose its suction and then fall back. They also, for water quality, low water, over harvesting. So over harvesting happened over in England, where they've got to import them now because, well, one, they have a lot of the same issues with dams and culverts, but also they're a prized food source. I learned at the American Fisheries Society conference in Spokane in August that Queen Elizabeth loves lamprey. Well, when she was alive, loved lamprey pie. So that was the first I had heard about that. And so there's over harvesting, climate change, and shifting oceanographic regimes. And 60 years ago, there was a count of 400,000 adults recorded at Bonneville Dam. And last year, there was less than 20,000. So we'll get to lamprey in the Elwha. And that's a macrothelmia in Indian Creek that we got out of the trap. So just a brief, the Elwha Watershed is 321 square miles. It's got 45 miles of main stem habitat. There's 8 major tributaries that are equal approximately 100 miles. And the Elwha is unique because 80% of it lies within Olympic National Park. And the 2 dams that were taken out on the Elwha, this is the largest dam removal undertaken to date. Whoops. So the lower dam, the Elwha Dam, was completed in 1912, and it was failed and rebuilt in 1914. It's a 33-meter concrete gravity dam, and in April of 2012, it was removed. The upper dam, the Glines Canyon Dam, was completed in 1927, and it's a 64-meter concrete arch dam, and that one was removed in 2014. So pre-dam removal, historic lamprey populations in the Elwha were not well documented. The Elwha River was once thought to be home to all 3 species of lamprey: the Pacific lamprey, Western river lamprey, and the Western brook lamprey. There's a lot of anecdotal observations. I spoke to a lot of tribal members, tribal elders, when I was doing my research for my project. And they always referred to them as eels and always say, ick, we wouldn't eat those. They used them as bait to fish. And observations by a local Elwha fisherman did go, and he had told me that the lamprey populations were large, that he always would see them in the 30s and 40s when he was fishing. And so Lower Elwha, Larry Ward, the former hatchery manager for the Lower Elwha tribe, in 07 and 08 got a tribal wildlife grant to kind of look at the population in the Elwha River. And this was when I was a technician. Larry hired me on to work with lamprey. And so this is where my first experience with them. And so in 2008, before the dams came out, there was approximately 20 amicetes that we found below the Elwha Dam. There were no lamprey in between the 2 dams or above the dams. So there was in 2006, the University of Idaho, there was a pilot radio telemetry study. And so they caught 33 Pacific lamprey from adjacent streams. They use several methods to capture them, capture pots, smolt trapping, electrofishing. They put radio tags in 18 of them and released them in the Elwha. So 2 of them stayed at the release site, which was River Kilometer 2.7. 10 of them moved upstream, 4 of them were at the base of the Elwha Dam, and then 2 were never detected again. So Pacific lamprey rapidly ascended into Indian Creek and into the Elwha system right after the Elwha Dam was removed. So in September of 2012, there was an adult in Little River. So there were lamprey that came right up. And so we continued to see adults in 2015 and then some ammosetes in 2016. So I applied for a U.S. Fish and Wildlife Tribal Wildlife Grant in 2016. And so that was to conduct a survey of Pacific lamprey distribution throughout the Elwha drainage after the dams came out. So we were going to electrofish, we were going to map their nest construction, and then track the migration of 40 lamprey with radio tags and pit tags that we implanted. And then we also wanted to pit tag some ammosetes to kind of watch their movement over time as well. And then we were gonna, we took samples from all of them that were large enough to get some, to look for species, to make sure what species we're actually seeing in the Elwha system. Because when they're juveniles, they're very, very hard to tell apart. As adults, you tell them apart by their mouth parts, but you got to have them in hand to do that. So genetic sampling is the only way to do that for sure. So as you might imagine, catching a lamprey is no easy task, especially when in a system when you've got a low abundance. One thing that we did know is, so the Lower Elwha tribe has smolt traps in a lot of the rivers and creeks to the west of the Elwha. And from previous years' experience, we knew that when we were disassembling these traps and pulled up the tarp underneath, that there was a lot of lamprey. So we would catch adults, and these were the lamprey we wanted to tag was lamprey that were fresh coming in from the ocean, because lamprey will tend to overwinter. They'll come in fresh, overwinter, and then spawn the following spring. Very few will spawn the same year that they come in. So we wanted to make sure we caught lamprey that were fresh coming into the system so we could track their migration. And so we got really lucky and we were able to catch a lot of them as byproducts of the smolt traps. We also made these lamprey pots, and they're kind of just tubes, PVC tubes with funnels on the inside, kind of like the crab pots. Once they get in, they can't get out. We were successful with those in Salt Creek. And as you can see in this picture, we kind of put them downstream of the trap. And so the fish coming up, they would nose around and they went in there. So we're pretty successful with that there. And so our adult migration. So we did get our 40 adult Pacific lamprey that we tagged, and we put radio tags in there as well as 8mm pit tags. And so these radio tags were individually coded, and the only downfall is their batteries, because they're so small, didn't last a whole long time. So, but the tag movements, we track them with a series of antenna arrays and by foot. We also did boat surveys. We also did fixed wing aircraft surveys, because just the lamprey like to hide underneath edges of streams, rocks, log jams. So it makes them real difficult to hear at times. And the topography in the Elwha with the rocks, and it gets steep. So flying was the only way we could really hear those radio signals. And this is Dr. Mary Mosier, and she is inserting a radio tag into a lamprey, an adult. So we anesthetized them, and then we made a little incision and we put the radio tag in there. So our juvenile migration, so we were able to surgically implant 200 of these amicetes with the pit tags. And so the Elwha system has pit tag antenna arrays in Little River and in Indian Creek. And the great thing about pit tags is you can they don't have batteries that'll die. So this tag will stay with this fish its whole life. So if it goes down into the Columbia or gets found somewhere else, if they scan it, they'll find it. There was an adult, so NOAA has pit tagged some lamprey in like East Twin River. And one of those pit tag lamprey was caught in a hake fishery off the Columbia. So you might get lucky every now and then, and that's a way for us to find out just how far these fish are going. And so after we tagged them, we recovered them, and then we released them upstream of the antennas to make sure that we would capture their movements and or their out migration. So in 2017, we were able to tag, like I said, we got 17 adults, and one of them was a dwarf Pacific lamprey. And I didn't really talk about that. The genetics aren't down, they can't tease them out aside from just saying they're Pacific lamprey, but the dwarfs are really small. They're the size of like a macrothalmia. And so we actually got one in Salt Creek that we're able to radio tag. And then in 2018, we tagged 24 adults. I really tried, we really worked hard at trying to capture adult lamprey coming into the Elwha system, but we were only successful in catching one coming in that system. The system's just huge and there's a lot of places for them to go. So only one came from the Elwha, all the rest came from East Twin, Salt Creek, and Deep Creek. Oops. Okay. Sorry. So like I said, we track them. We track them mobily on foot. We had 11 fixed sites along the Elwha system, and 7 of them were operated with car batteries, and 4 of them we got lucky enough to be able to plug into electricity. We also had antennas on our vehicles where we could drive up and down the river, and like I said, fixed wing aircraft. So these are some graphs and with dates. And so the dates and the river miles of our tagged lamprey. And so there were in these, our sites along the river that had they had computers that were run off. I forgot to say that. So there's computers with the radio antenna that the batteries ran that would pick up these radio signals as the fish went by. And so then we would go download that information, and we could tell how long it took the fish to get where they were going, and track their movements if they went up and down. But generally it seemed like it took them about 2 to 3 months to go, 2 to 4 miles. So this map, so the little lightning bolts are our fixed sites along the river, and then the little blue squared numbers are the river miles, and the little green fish is the lamprey. And so this, look at my notes real quick. I get them confused, but so this one was the first lamprey that we documented going above both of the former dam sites. This one went right before Boulder Creek, and we released this fish July 13th of 17, and on 10/25/17 is this uppermost location, and then we last heard that fish on 10/31/17. So the batteries would die. So that was the hard part when you're dealing with a small animal and a small battery. And so this is a different fish. And this one was this fish, the battery lasted the longest. We are actually able, we released her. She came in July 13th of 17, we released her, and she went up into Indian Creek, and she did exactly what they do. She found a place to kind of hunker in Indian Creek, and she spent the winter there. And then 10 months later, which we couldn't even imagine, because the batteries weren't supposed to last that long, on May 10th of 18, we heard her again at the outlet of Lake Sutherland. And that was like really exciting. And so then we tried to figure out if she went into the lake or not. We really wanted to document that. And so we really tried to make an underwater antenna, but it didn't work out, and we didn't hear her again after that. But this one was really cool, and this was a female. So we know that lamprey get predated on, but we weren't expecting our radio tag lamprey to get predated on by river otters. After a while of hearing the same signal in the same area, we would track in on it, and we actually found, you can see right here, is a radio tag from one of our fish in some otter scat. And so this, obvious documentation of otter predation on the lamprey. This is another fish that was predated on by otters. And we tracked this one. You can see the antenna sticking out right here. We tracked in on this one in a den, and we kind of tore the den apart a little bit to get at the radio tag. And as you can see, this radio tag was chewed on and spit out. And then, so I'll get, just wanted to talk about the genetic results. So we published this paper in Transactions of the American Fisheries Society, and in August it was awarded the Robert L. Kendall Award for Best Paper in Transactions of the American Fisheries Society of 2004 to 2021, which like I was telling Megan, this is like something that I never even dreamed of or even knew existed until we found out about it. So pretty exciting, pretty proud of it. My first grant. Yeah. So just a little bit of the genetics. So we did some SIB ship baseline. And so knowing this, it's useful for showing the natal origins within the Elwha. So because they're poor swimmers, the ammocetes can get like moved around in the system just by flows. And so what we were able to find out was that Indian Creek is a large source of production in the basin. And then the age composition shifts to older ages between the creek mouse and the river mouse, which kind of makes sense of what lamprey do. We also were able to find out that, and to report that there was a 12-fold increase in population within 3 years of dam removal. 41% of the production of Pacific lamprey in the Elwha Basin come from Indian Creek. So that's pretty huge. And Indian Creek's a pretty special system. It's lower, it comes out of the lake, so it's warmer, it's lower gradient, and it's just a super producer. So let's see. So one of the other things that we found is that the 40 lamprey that we moved into the Elwha from the other rivers, the genetic analysis showed that all or nearly all the lamprey in the river were a result of colonization, not production of those transplants. So these findings support that the strategy of natural recolonization over time rather than transplanting more lamprey from other areas. And so in conclusion, the radio-tagged adult Pacific lamprey migrated approximately 2 miles above the former Glines Canyon Dam. And so this is a big deal because it was thought that lamprey don't go where they're not detecting pheromones given off by ammocetes in the sediment. And to date, there have not been any ammocetes found above Glines Canyon. So we haven't been able to document successful spawning above there, but we had several radio tagged adults that went up there nosing around looking for a place. So Indian Creek, which is a tributary to Elwha, like I said, contributed 41% of the larval and juvenile production in the Elwha. Our effective number of breeder estimates for the Elwha River, like I said, indicated a 12-fold increase in 3 years following dam removal. And these results indicate that rapid recolonization within the Elwha River was taking place by Pacific lamprey. And so, this suggests that restoring passage to adequate habitat is a highly effective approach for reestablishing populations of Pacific lamprey in coastal systems. There's a lot of people to thank, and I hope I didn't miss any, but this was definitely a lot of entities and a lot of folks worked really hard on this project. And here's just some pictures. I had an AmeriCorps student that helped me, Nathan. He was really great little surgeon putting radio tags in, and then Justin, my technician. And this is Sonny Sampson down below. He was actually releasing the first radio tag lamprey in the Elwha. So that was a pretty special picture. So with that, I can take any questions.
That was fantastic, Rebecca. So we have one in the chat. Someone asked if you have ever eaten lamprey.
Kim, no. I have not eaten lamprey, but I would if given the opportunity. I just have not had the opportunity.
We should try it sometime, Rebecca. We need to eat some lamprey.
Yeah, we'll have to go get some in Eastern Washington.
I'll have to get some good flavor though.
Okay, we had another question come in. What do adult lamprey eat when they come back to fresh water?
Okay. I knew I was going to miss some stuff, and I'm sorry. I'm glad you brought that up. So they don't eat anything when they come back into fresh water. They live off their body stores, and so lamprey can lose up to 1/3 of their body size overwintering. And so the lamprey that are coming in from the ocean will be a lot bigger, they're brighter, they're silver. And lamprey that have overwintered, which we have caught a lot of in the traps, they're brown, they turn, their eyes kind of get cloudy, and so we know that they've been in the system for a while and that they're older. And the other thing to watch and look at is their dorsal fins. So they have two dorsal fins on top, and if you can get like a finger or two in between those dorsal fins, that's a fish that hasn't been in the system very long. If those dorsal fins are close to touching, then that fish has overwintered already and getting ready to spawn. So Kevin, lamprey do not return to their natal streams like salmon. They actually key in to pheromones given off by juveniles in the system. So they could leave the Elwha and hatch and like latch on to a bigger fish, and they could leave the straits and go down the coast, and then 3 years later drop off and head up to the Columbia. So yeah, they don't home.
Yeah, they kind of lose that opportunity by grabbing onto other fish. They don't know where they're going to end up when they're ready to spawn, huh?
Exactly. And that's why they're considered panmictic. Their genetic is just, yeah, they're not specific to any watershed.
What was the word you just used?
Panmictic. And so black-tailed deer are another example of that too. Like Squem to Joyce, they're the same. Genetically, yeah.
Did you see the question, if you could describe their ectoparasitism more?
Oh, no. So ectoparasite, it just means a parasite on the outside. So lamprey in their adult, when they leave as a juvenile macrothalamian, head out into the ocean, they'll latch onto any fish. They're opportunistic. So they'll latch onto any fish that's larger than them. And their little mouth, their mouths have like teeth. And so they're actually being studied in medicine for their, they kind of cut in the skin and they use, oh gosh. So they can, I'm drawing a blank on that name of the word, but anticoagulant. So they inject that in there so they can suck out the body fluids. And so they're being used in medicine for that too. So when I say an ectoparasite, that's just like a parasite on the outside. And they do seem to prefer bottom fish, flat fish. And then let's see. Oh, so Kathy, why do lamprey latch on? So they latch on to feed. That's how they eat when they're adults. So they filter feed as juveniles, and then they are parasitic as adults. And then when they come back in the freshwater to spawn, they don't eat at all. Yeah, I think they're just relying on blood and other body fluids, Kim, when they parasitize in the saltwater. Yeah. So they don't kill. There's no evidence of them killing their host, but they can, you can see scars on fish from them. And a lot of commercial fishermen don't like that because then their fish is worth less, but it doesn't harm the fish and it doesn't harm their meat or anything like that.
Okay, does anyone else have any last minute questions for Rebecca? If not, then we did record this video. So if anybody wants to go back, we're going to be putting it on our website under our past workshops. So you can come view it whenever you want. And we'll probably also send it out to everyone that registered for the webinar, because we had quite a few folks that weren't able to attend live and wanted to watch the recorded version. Gosh, thank you, Rebecca. That was amazing. Lamprey are just such cool creatures.
They are really cool, and they've got a really great life cycle. I mean, they've been around for millions of years for a reason.
Yeah, no kidding. Well, who knew they were so fascinating? And also, it's so neat that they are such an important part of the food source, historically. And I would have never expected that out of lamprey.
Well, thank you for having me.
Oh, definitely. Look forward to doing more of these webinars with you in the future. And thank you everyone for attending. And with that, everybody have a great rest of your evening.